First of all, thank you everyone for joining this webinar today. Thank you for carving out time and joining us on this webinar about AI agents for business leaders. Two of my colleagues with me in the webinar, Talvinder and Gurpreet, who will help me manage the attendance of the webinar because people might still be joining while we'll be doing this webinar. People might still be waiting in the green room and the chat and the Q&A section as well. So thank you, Tali and Gurpreet. And yes, okay, let's begin. So we will have about 10 minutes towards the end of the webinar to take up any questions. If you have any questions during the webinar, please feel free to paste them in the Q&A section. Tali and Gurpreet will make sure that those questions are taken up towards the end and we will answer those questions. Okay, let's get started. So we'll quickly start with what all we will be covering in this webinar today. All the learnings that you will take away from today's webinar. So the first thing that we are going to learn is what are AI agents and their internal components. The second thing that we'll take a look at is the business impact of generative AI in general and AI agents to be specific. And the third thing we're going to look at is some of the most common misconceptions about AI agents that have come up in a lot of my conversations with business leaders. Then we'll look into a specific types of AI agents and their examples from the industry. And then we'll also look at how can you evaluate your use case and see how you can adopt AI agents to solve your problem. With this, we'll move on. And before we dive deep into the AI agents, a little bit about me. My name is Bharat, and I am the CTO at Ultram AI. I have 10 plus years of experience in software development, machine learning, and AI. And at Ultram AI, we are solving this problem of enabling ethical and responsible use of AI for enterprises. I still love coding at night because I absolutely believe that great ideas don't follow 9 to 5. And I'm always passionate about real-world implementations of the latest in software and tech. With this, we'll dive in. So let's try to understand what exactly are AI agents and what are the components that make the magic happen. So a generative AI agent is a software application. It has the ability to understand a particular task in a natural language format. Also, an AI agent is something that acts on the world to achieve a specific goal or an outcome without any human intervention. Agents, they specifically consist of three main components: a model, a set of tools, and an orchestrator. And when we say a model, it's like any language model. It is this combination of the language model plus the set of tools and the orchestrators that make the magic happen. Let's now take a quick look at a simple flow of an AI agent by looking at an example and then understand each of these components in detail. So in this example, if you see that a user who wants to book a flight journey is using a chat interface, let's say, and they want to check their flight options. The user inputs a query in the chat specifying their starting point and the destination of the journey. The agent accepts the inputs and starts to reason, starts to think about the next steps. And then the agent uses a tool, which in this case is a flight API, and external data from the flight API server. It then gets the external flight details and nicely presents the option to the users in the chat interface itself. Now, if you look at this example, a couple of things to be noted, which makes this solution specifically a generative AI agent. So the first thing to notice is that user provided his query in a natural language format, and the results were presented to the user in a natural language format too. And the second thing to be noted here is that the model used in this AI agent, which is GPT-4o in this case, had no knowledge of the latest flights available as per user's request. And hence, the agent used a tool, which is a flight tool specifically in this case, to get the latest options available for the user. So we can see this in the diagram, how orchestration, which is all the thinking and making the model tools work together, makes this whole process happen. Now let's lay out all these components in detail, especially the orchestration part that we should focus on. So if you look at this diagram now, here, the big blue block that executes the complete functionality is what we call the agent runtime. It consists of this orchestration block, model block, and tools block. We're going to specifically look at the orchestration block here to understand what happens within the agent. So in our example that we looked at previously, there was a profile assigned to an agent with a clear set of instructions, and the agent knew about a goal that needed to be achieved. Also, the orchestration layer contains a memory, which could be a short-term memory or a long-term memory. It will be a short-term memory if the agent is only retrieving the information for that particular instance of a task, just booking a flight for one time. That is a short-term memory. Versus orchestration layer in agents can also retain long-term memory. For example, and if we look at the previous example, if we also retain the information about users' profile and their preferences, that can be used across multiple instances of the agent execution. And the other thing that orchestration layer has is model-based reasoning, which is where agents create their own model about the environment and they reason around it. Now let's take a quick look at each of these components in detail and understand how exactly they contribute to an agentic solution. So first we will look at the model. The model in the AI agent, it can be a small language model or a large language model. It can be any language model. Can be ChatGPT, can be Claude, or it can be a custom tuned or trained model based on your use case. The model in the agent is used to make centralized decisions. An important point to note here is that the choice of the model directly impacts the performance and the accuracy of the agent. Because at the end, apart from all the logic that is implemented in the orchestration block, model is the real brains of the agent. And it's not always necessary to use only one model for an agent. The more sophisticated agents these days, they use more than one models for achieving a particular goal. Next, we will move on to another the second component within the AI agent, which is a set of tools. Now, foundational models like GPT-4o or Claude, they cannot directly interact with the outside world. They have no knowledge of what's the latest that is happening out there. And this is where the need of tools come into the picture. Tools provide external context to the agents and help them make relevant decisions. Some of the most common tools that are used in AI agents are web APIs, databases, or document repositories. Could be public document repositories or private document repositories. And now we will move on to another important component, which is the orchestrator in the agent. Orchestrator, as the name explains, controls the overall flow of everything that is happening within the agent. Orchestrator implements a process which is a cyclical process where agent takes in the information and keeps on reasoning internally, and then keeps on taking actions based on that reasoning. The action here could be using a tool, an API, or a document, or a website, or this can be anything related to getting additional data context. Or it can be calling another LLM as well, which can also be part of the actions to make some specific decisions. More sophisticated agents, the more sophisticated is the agent, the more complex the orchestration layer is. Now, before we finish understanding the AI agents, something we talked about, which is very important for businesses and enterprises, is the external data context. So let's focus on it a little bit more to understand how exactly it works. So the data store is a type of a tool, or I would say the most common type of a tool that is used in the AI agents. We know that the language models, they don't have any external knowledge. They don't have any knowledge of what's happening out there. They can't stay up to date by themselves. And this is where the need of data stores arise. And these data stores can be private documents, could be websites, or could be any other structured data sitting in your Excel files or databases, or even in your enterprise applications. This is one of the most important aspects that has brought language models to life, and that has made the concept of AI agents possible in the real world. Now that we have covered the definition of AI agents and some of the most important components in the AI agents, we will now move on to the business impact these AI agents and generative AI in general is having. I'll quickly take a pause here and would like to say that if any one of you has any questions regarding understanding the AI agent, please feel free to drop your question in the chat. We'll make sure that we'll pick it up towards the end of the session. We have dedicated 10 minutes toward the end of the session for the Q&A, and that's where your question will get picked up and we'll answer it. Okay, so let's now try to understand the business impact. The significance of generative AI agent followed by, the significance of generative AI in general, followed by AI agents to be specific, cannot be overstated. Previously, machine learning implementations required extensive human guidance. They used to operate within narrow domains. Whereas now, generative AI and related agentic AI systems can autonomously manage complex processes across various organizational functions. This is what is driving the real adoption across industries, especially the ones that are looking to streamline their operations or enhance their decision-making and automate their business processes. Next, we'll take a look at the business impact of generative AI in general, even before the concept of AI agents materialized. The first example that we're going to take a look at is from content creation and marketing. So this commercial bank called AK Bank, they used Jasper for crafting personalized marketing messages. They automated digital marketing processes, reducing their content creation time by 40% and improving the campaign click-through rates by up to 70%. An important point to note here is that Jasper was primarily used for crafting personalized marketing messages and push notifications for the end users. The other example that we get to see from the industry regarding the business success of generative AI is video generation for sales. So this company Xerox, they used Synthesia's AI video platform to cut their video production costs by about 50%. They reduced the creation time of these videos by 30%. And the platform allowed them to localize their sales training content. in multiple languages, and they were able to train over 1,000 plus sales reps globally. What an achievement there, just by using generative AI. And next, we look at another example, which is from HR, automating the HR interview process. So Great Southern Bank collaborated with HireView to build an AI agent, reducing the average time to hire from 40 days to 23 days, and cut out the screening time by about 60%. This allowed the bank to handle more roles while improving the candidate experience, achieving the overall satisfaction score at 87%. The platform also enabled hiring managers to assess higher quality candidates early on in the interview process. Again, big gains. Now that we have looked at a few examples of the success of generative AI in the industry, even before the AI agents came into the picture, let's now look at some of the business success that AI agents have already achieved in the market. So the first example that we look at is from customer support. Lenovo uses AI agents to handle customer interactions across multiple channels. This includes their online chat, their voice mails, and their emails. These AI agents can manage up to 70 to 80% of the customer issues without any human intervention. The implementations of these AI agents at Lenovo has led to double-digit productivity gains in call handling times. Additionally, Lenovo's marketing teams have benefited from generative AI by reducing the time to hire to create marketing pitch books by 90%. This resulted in substantial savings on the agency fees. Let's look at another example, which is very specific to AI agents' success in the industry, is from business intelligence. BMW's AI agents powered Echo platform, which boosted their productivity by 30 to 40%. It optimized their supply chains and delivered real-time customer insights. Even in this example, it's the GPT-based agents that transformed enterprise data into intelligent insights and actionable responses. Another popular example from the industry where the success of AI agents is already proven is Shopify's AI agent called Sidekick. A few months ago, Shopify introduced Sidekick, which is a generative AI agent designed to help online store owners manage various tasks. Sidekick in Shopify assists in setting up discounts, summarizing sales data, streamlining operations, and enhancing the overall management experience for the Shopify users. This is a very specific example of a multi-agent system that Shopify has implemented. Sidekick can also analyze sales trends in real time and suggest reasons for declines in sales. It can even automatically adjust prices and update the homepage of the e-commerce websites, and even change the entire store design that the new theme and the new product focuses on. Sidekick's ability to understand the specific context of each store and act on behalf of the merchants provides its powerful implementation as a multi-agent system. A great example implemented by Shopify. Now, before we move on to further sections, I wanted to share some of the other use cases of AI agents that are being worked upon, or one of the most common ones that are productionized out there. The first one being, again, from supply chain and logistics. AI agents can now execute entire supply chain workflows seamlessly, where, let's say, human workers can simply just input their goal. Whether it is about securing the low cost or it's about the fastest delivery, an AI agent can do the rest. AI agents can find suppliers, optimize the logistics, and even initiate necessary actions, making supply chains more resilient and efficient than ever before. The next example or the use case that we can look at is from risk reduction and security perspective. AI agents are already transforming the enterprise security and risk management by actively by proactively managing the risk detections rather than reactively. In security operation centers, these AI agents can continuously scan for new and emerging threats, investigate anomalies, and even take corrective actions, all without human intervention. And the same applies to risk management as well. AI agents can detect unusual activity, analyze the pattern to determine if they indicate fraud, and respond automatically. Another example that we can look at is the use case around call centers. Agentic AI is transforming call centers at scale, especially by building on the efficiencies that were introduced by traditional AI. Today, AI agents don't just assist, they orchestrate entire customer interactions. They can analyze customer sentiment in real time, they can review the order history, they can access the company policies, and they can provide accurate responses as well, all happening simultaneously. This level of automation enhances efficiency, reducing the wait times, and it delivers more seamless and personalized customer experience. So these were some of the use cases that have already been implemented in the industry and some of the additional use cases that I wanted to share. If you have any questions regarding any of these use cases, please feel free to drop your question in the Q&A section. Or if you have any ideas or any new use case that comes to your mind, please feel free to drop in that too. Happy to have a discussion offline later on. So now we will move on to some of the most common misconceptions about AI agents. In my conversations with business leaders, I have seen that AI agents are being misunderstood because of the lack of information in terms of their real usage, and the information is scattered at the moment because a lot is happening in terms of technical progress, but very less is happening in terms of making these AI agents a reality in production. So let's look at some of the common misconceptions, where the first misconception is that AI agents are just glorified chatbots. Now, this is not true. The reality is that chatbots and agents are fundamentally different in terms of their complexity and functionality. Chatbots are all about retrieving the data and answering the questions, whereas agents, they are about taking actions. This differentiation of just answering the question versus taking an action is one of the important ones to really differentiate between a chatbot and an agent. Most of the times, chatbots use predefined rules, scripted responses to answer questions. This kind of rigidity limits their usefulness. Chatbots don't understand more complex contexts, and they can't be creative in their problem solving, and definitely can't take any actions. Whereas AI agents go far beyond a simple Q&A. They make the decisions and they learn from their environment. The next biggest misconception about AI agents is that AI agents are unpredictable and uncontrollable. Obviously, this is not true. Again, the reality is that most effective AI agents today are using sophisticated tools, techniques, and guardrails against errors. And they have safety and trust built at their core. Although it is very easy for developers and technical people to take shortcuts while building AI agents, which sometimes can lead to unpredictable and uncontrollable behavior. So this means if designed the right way, AI agents can absolutely be predictable and they can be controlled. The next biggest misconception about AI agents is that they are always fully autonomous. AI agents don't have to be 100% autonomous. Their level of autonomy varies depending on their purpose and the complexity of the task for which they are built for. However, agents are most effective when they are paired with humans. And in a semi-autonomous situation, agents support workers in decision making and carrying out tasks. And usually they require human intervention as well to approve decisions. But then there is a hybrid approach as well that is gaining popularity in some of the use cases, where agents don't always have to be fully automated in taking action, but they do understand the request and reason behind it as to whether they can take action on their own or whether they should send a request for a human intervention when needed. Now that we have covered some of the most common misconceptions about AI agents, we will now look at the types of AI agents. When I was learning about this myself, I found that there are different ways in which we can categorize AI agents. But the most relevant one to this session is the types of AI agents based on their decision logic. Decision logic in AI agents define how an AI agent process information, how they evaluate options, and select the best course of action. This kind of categorization of AI agents highlights their range of capabilities and levels of autonomy they can achieve. And it makes it easy for businesses to understand what kind of implementation will be helpful for them, or even to understand what kind of implementations are available out there to make sense as per their specific use case. In this type of categorization, from simple rule following systems to sophisticated adaptive agents, understanding these categories helps businesses choose the right tools. So the first type of agent that we will start with is simple reflex agent. Simple reflex agent are the agents where their decision-making process is basic. They just execute a predefined action when they encounter a trigger. While they are limited in their flexibility, these agents can really excel in environments where clear and consistent rules are in place. One of the simple examples of simple reflex agent can be a banking system, where an agent can implement the transaction flagging, where an agent can flag transactions that meet predefined criteria for potential fraud. Or maybe an insurance, where reflex agents can automatically send an acknowledgement email to policyholders upon receiving a claim submission. The next type of AI agent that we'll look at is model-based reflex agents. Now, these agents create an internal model of their environment. Let's not confuse the word model with the language model. The model here means the internal model that agents create about their environment. These model-based agents, or the model that they create, it helps these agents to adapt to partially observable environments, like the past states, and respond effectively to changing conditions. One of the common examples seen in model-based reflex agents is again in supply chain for inventory tracking, where agents used model-based approach, especially to monitor the stock levels and then project future demands and adjust the orders as needed. Another example from banking, where a model-based agent could just assist in loan processing by maintaining an internal model of the applicant's profile and the current underwriting guidelines. We'll now quickly move on to the third type of AI agents, which is the goal-based AI agents. Now, goal-based AI agents are versatile. This makes them suitable for tasks with multiple possible actions, each with different implications. So an important point to be noted here, because we'll be discussing another type of agent going forward. For goal-based agents, it is the multiple possible actions that agent has to evaluate and see which action is going to have what kind of implication before it takes that route. A common example for goal-based AI agent could be logistics routing agent. Logistics routing agents are used to find optimal delivery routes based on factors like distance and time. Or another example could be industrial robots, who can follow specific sequences to assemble products, adjusting their actions to achieve predefined assembly goals. Another type of agent, which is slightly different from goal-based agent, is utility-based agents. Now, these agents use something called utility function for the tasks that have multiple possible outcomes. So in this case, the whole outcome can be more than one. An easy example to understand utility-based AI agent is financial portfolio management agents that evaluate investments based on factors like risk, return, and diversification. These agents operate by choosing options that provide the most value. Or another example for utility-based agents could be resource allocation systems, where an AI agent has to balance resource usage with energy consumption and with the production goals to maximize the overall efficiency. Let's look at another type of AI agents called learning agents. These agents or learning agents can also be considered as predictive agents, since they use historical data and current trends to anticipate future events or outcomes. One of the common examples of learning agents can be recommendation engines in e-commerce sites. For a while, industry has already been using machine learning for recommendation engines, but once replaced with agents, these are the type of agents that we should be using in recommendation engines, where we want to refine the product suggestions based on the user interactions and preferences. Or it could be a customer service chatbot that can improve the response accuracy over time by learning from the previous interactions and adapting to the user needs. Another type of AI agent is, just because how the system is put together, is multi-agent systems. As the name explains, here several AI agents work together, with each AI agent specializing in a specific task, allowing them to work more complex and interdependent workflows. A common example could be a smart city traffic management system, leveraging multi-agentic system to regulate the traffic by managing the traffic lights, by monitoring the congestion, and suggesting alternative routes. The last category, or the last type of AI agents that we're going to look at is hierarchical agents. Agents operate across different levels. They combine multiple agent types into a hierarchy, with the lower level agents handling specific tasks and higher level agents managing the broader objectives. One common example of multiple agents working together as hierarchical agents could be quality control agents, where a low-level AI agent inspects individual items and a high-level AI agent then analyzes the data to identify the patterns and improve production quality. So these were some of the most common types of AI agents based on a specific category, as I originally explained, which is the decision logic, how they process the information. If you have any questions regarding any of these types of AI agents, or if you want to have a detailed discussion as well offline, please feel free to send a message in the chat. And questions wise, we'll be answering those questions towards the end of the webinar. Okay, now that we have covered the types of AI agents, we'll quickly move on to the most important section. How can you adopt? How can you evaluate whether Gen AI agent is right for your use case, for your business, or for the problem that you want to solve? So for this, I'm going to share a 7-step framework that you can perform using this assessment to understand whether Gen AI agents are right for you. If yes, then what type of agent? And what we also plan to do is we will be doing another follow-up webinar where we'll be talking about the AI agent adoption in detail and how to carry out this assessment in detail in your organization. So the first step in the framework that we need to conduct is understanding the purpose and the problem. You should be able to identify and clearly define the problem that you want to solve. And then check if the AI agent is the appropriate solution. Now the question is, how do we check that? So the first thing you do is to consider whether the problem requires generative AI capabilities, or can it be solved using simpler solutions? This can be done by identifying potential generative AI use cases as part of the problem and its solution. And also, another important point here, to establish clear and measurable success criteria for what good looks like. And as I mentioned, we will be talking about this step and all the remaining steps in detail in our next webinar. We'll move on to the second step of this assessment, which is about resources and readiness. This is where you check whether you possess the necessary organizational resources and the readiness in terms of technical infrastructure, in terms of data quality and the data availability, and in terms of internal expertise and capabilities. And then we move on to step 3, which is all about ethical and compliance issues scrutiny. You need to identify the relevant compliance requirements that may impact your Gen AI agent implementation. For this, you will have to do regulatory compliance analysis, have to look at the bias and fairness evaluation, whether there is any data bias or any fairness issues in your use case, in your data, and also look at any security and privacy considerations that you might want to adhere to as part of this process. And the next we'll take a look at is cost benefit analysis. A thorough financial evaluation to determine whether Gen AI agents will deliver sufficient value is really important. Implementation cost assessment should be done, especially with regards to Gen AI agents, because they use a lot of compute and a lot of other resources. It's a new technology. It uses different type of resources that comes at a cost. And the value generation projection. What value will you be generating after the goal is achieved? And also the ROI timeline analysis. That when do you think, if the use case or this Gen AI agent goes to production, when do you think you will have the ROI as you expected in place? The next to perform as part of this assessment is integration and scalability evaluation. Now, integration assessment with the existing systems is absolutely critical. With most of the businesses and the organizations, what we see, there are already a lot of systems in place where sometimes the data is sitting in silos and it's hard to bring everything together. And also the ability of the AI agent to scale as the need evolves. So system integration assessment should be the topmost priority. And the scalability requirements as well, along with the performance expectations. Because AI agents use language models and they have these integrations with the external tools, they are not as quick as any other software program that we have traditionally written. They take their own time based on the complexity of the task assigned. And the complexity can change on the fly. So it's better if we understand the performance expectations of the use case beforehand. The next thing that we need to do, which is the sixth step in this framework, is understand the user experience and the adoption potential. Even the most technically successful GenAI implementations, they fail if they don't deliver a positive user experience or if they face any adoption barriers. So we need to be really careful about the user experience design, the change management planning, and stakeholder impact analysis to make sure that you deliver the right experience to the users after you are able to build that agentic capability. And the last but not the least step in the framework is long-term success requires ongoing monitoring. It's all about stability and support structure. There has to be a system in place where you can continuously monitor, maintain, and improve your agentic AI implementation. So there has to be detailed and well-documented reliability requirements, monitoring and evaluation mechanisms in place, and continuous improvement process to make sure that the implementations are improved with time because the technology is changing at a really fast pace. So these were the 7 steps of the framework that will help you adopt generative AI agents in your organization. And we will talk about each of these steps in detail in our follow-up webinar. And this brings us to the conclusion of today's session. The most important takeaway from here, that AI agents are not just the future. They are not the future of businesses. They are happening right now. The question is not whether you will be able to implement them, but the question is whether you will be leading the transformation or whether you will be following the transformation. Thank you everyone for giving your time and joining us at this webinar. And now we will open the room for questions, if any. Please feel free to drop your questions in the Q&A. Okay, I see. Quite a few questions have been asked. Thank you, Justin. Let me quickly take a look at the questions and we'll answer them. Okay. One of the questions is a very good question, that can existing chatbots be enhanced with AI agents? That is absolutely possible. Existing chatbots can be enhanced with AI agents. And this is where the point that we discussed about integrating into the existing systems come into the picture. AI agents does not have to be built standalone always. It is a functionality that can be added to your existing system. Could be an application or could be a chatbot. Let's look at the next question. What security concerns arise when AI agents handle sensitive data while performing tasks provided by the users? Okay, I think the question itself contains a bit of an answer in it, that in this case, what we are saying is the data is sensitive, and what security concerns arise if the sensitive data is being dealt with in the agentic AI implementation. So number one, if you look at the state of the art models, they are being provided by external providers. Companies at the moment are not able to keep at par with the level of intelligence these state-of-the-art language models are achieving. And these models are really important component within an agent. So that means most of the companies will end up using OpenAI, Anthropic, or Google to get LLM as a service and get it integrated into their agent. And that's where the whole issue arises, which is the sensitive data might get leaked. It is confidential information, and for information protection reasons, it has to be taken care of as part of the agentic workflow. Let's look at another question. In financial evaluation criteria for selecting agentic approach, what are the different methods to calculate the compute costs? Great. Okay, so there are there are different methods of calculating the compute costs, but a lot of these methods are shared by the providers or the cloud providers themselves. This is one of the challenge that industry is facing at the moment to understand the compute costs of an AI agent in production. It's not even in like the dev environments or when the AI agent is being built. We can still understand that. But in production, it might get really complex because we don't know how many times an AI agent might end up using an LLM. So the best way to do, I think, to do this, to have a sandbox environment or a pre-prod environment where the agentic workflow is monitored and having and we should be doing a real world tests in that environment. But yeah, there are a lot of steps that can be taken into the structure of this AI agent where while this is being built to help us monitor the agent in detail and even flag all the outliers or any anomalies regarding the credit usage or costs. So that is something which is a bit more sophisticated, I would say, as per this webinar. And I think the question was asked by Rishi. So Rishi, I'll be happy to follow up and we can have an offline discussion on this if that helps. Let's look at another question, which is regarding the traffic flow management example, which is an age-old problem. Yes, thanks for your question, Naheem. Had elaborate traffic management systems, but before we probably were not that flexible to change or were not intelligent, where were only as good as the rules provided. Yes, that is absolutely correct. So I think Naheem says that traffic management systems so far were mainly rule-based. All of the logic was coded right into the solution as set of rules. You can think of it as like if-else conditions and making the whole traffic management flow happen. But now it can be a little bit more smarter, where all the edge cases that are not covered in the rule-based engines can be taken care of by these agentic AI implementations. Plus, the decision these agentic AI implementations might make in this case, this use case, traffic management use case, will be a lot more intelligent and meaningful. Another question we'll take. How do you select an agent builder tool? For example, LangChain, LangFlow, specific for a use case? Great question. So there are a lot of tools available out there to help you build AI agents. And the answer actually depends. If you are just doing, let's say, a POC and trying to prove a use case, it's really easy to get started with something like LangChain or LangFlow. But then if we are planning to build an agent for production in large organizations, there is a lot that has to be considered. Libraries like LangChain, they still don't provide integrations with the existing tools and techniques that are in place in large organizations. So there are some sophisticated platforms out there that help you drag and drop and build these agents. But there is always this custom logic layer that you will have to build on top of it to make it a success in a real enterprise environment. Okay, I guess those were some of the questions. If you guys have any other questions, please feel free to drop in the chat. Otherwise, we are coming towards the end of the webinar. And thank you everyone for joining this webinar. I really enjoyed it, presenting this information to all of you, myself. And thank you, Tally, and thank you, Gurpreet, for helping me with managing the session, the chat, and the attendees. Great, perfect. Thank you, everyone. I think we can attend our webinar here. Thank you, everyone, for joining, and looking forward to our next webinar, which will be more about the adoption of generative AI agents in organizations. Thank you.